Hello my dear friends, very good morning to all. So in the last class we discussed about the maximum power transfer theorem in AC circuits. When we gave an impedance of value ZL as load side, and if it having a source impedance of ZS, then what will be the maximum power transfer? I mean, what will be the value of maximum power at the load side? Okay, when at different conditions, right? When RL is variable, or when XL is variable, or when RL and XL both are variable in nature. So today we are going to discuss some important problems regarding those maximum power transfer theorem in AC circuit as well as in DC circuit. Okay, let's do one by one. Please write a question. So please write a question, my dear. So this is Vx, this is 100 ohm, and this is 400 ohm, and this is 200 ohm, and this is 40 volt. So up to this considered as a load. It's already given in the question, this is load. So our question is, determine the value Vx. Determine the value of Vx for maximum power transfer. So this type of question you may expect in your examination. This type of question. See, look wise it's very simple, but you have to know the basics first. Then only it can be easily solved. Otherwise, you will be stuck. Somewhere. Okay. So this is the question. Observe the question carefully. What I feel. So there is a 40 volt source and 200 ohm resistor in series with that. So obviously this will be this we can consider as a what? ZS. Since it is a DC circuit, simply you can consider as R Thevenin or RS. No issues there, because it is a DC circuit, no? So R Thevenin or RS. And this whole will be considered as the load. We have to find Vx. What is the value of Vx? Is it clear? So how can we find? So for maximum power transfer, I already told you that for maximum power transfer, RS will be equal to RL, or R Thevenin will be equal to RS, right? For maximum power transfer, right? Maximum power transfer, I can write R Thevenin or RS will be equal to what? RL. R Thevenin or RS will be equal to RL, right? So here the load resistance RL is not purely RL only. It consists of two resistors and a voltage source. So it is not exactly contains all resistance or all load, purely load. It is not purely actually a load. It contains a voltage source. So yesterday I taught you something, that is, we can convert that voltage Vx into a resistor. That is called the substitution theorem, right? Yesterday I told you what is meant by substitution theorem. So according to that substitution theorem, we can do something here. That is, I can modify my circuit. Like, listen very carefully. I can modify my circuit by, this is nothing but 200 ohm, no issue there, 200 ohm, and this will be, see, this will be, so this is, I can made like this, Vx and having a value of Rx, and this is nothing but 100 ohm, and this is nothing but 400 ohm. The concept is very important here. The concept is very important here. See, so this load side, right? This load side. So again I can mark like this. This is a load, no? So again I can mark like this. This is the load, right? This is the load. So load side I converted that Vx into what? A voltage Vx into a resistor having a voltage drop of Vx, and the value of what resistor is nothing but Rx. Is it clear? Is it clear? So we have to find Vx. Okay, that our ultimate aim is to find Vx only. Okay. See, if this is 200 means the whole load will also what? 200, right? If this is 200 mean the whole load will be, that means the effective value of this will be what? Effective value of load will be equal to what? 200 volt. Then only maximum power transfer what theorem will be applicable. It is given that under maximum power transfer. So for maximum power transfer, what is that? Effective value of load will be equal to what? This 200 same. Then only Rs will be equal to RL. Rs or RThevenin will be equal to RL means the whole load will be equivalent to what? 200 ohm. The whole load will be equivalent to 200 ohm. If this is 200 ohm means what will be the total current I? What will be the total current I? I can write I is equal to nothing but total current, right? Total current which is equal to 40 divided by 200 plus 200. Why? Because already 200 RThevenin as 200 here, and RL value also equal to what? 200 for maximum power transfer. Then only maximum power transfer will happen, right? So total current I will be equal to 40 divided by 200 plus 200, which is nothing but what is that? 40 divided by 400, or simply I can write like what? 1 by 10 ampere. So that is the total current. That is the total current, right? That means up to this value it is 1 by 10. Then what will be here and what will be here? See, this is 400, right? This is 400, right? The whole will be 200, no? So these also be like what? 400, right? These also be like 400, right? This is 400. If this is 400, then only the effective combination will be 200. Then only this will be equal to that. Okay? Please note carefully. Please note carefully. If this is 400, if this also be 400, then only the effective parallel combination of 400 plus 400 and 400 will be what? 200. Is it clear? That means I can write like this current will be 1 by 20 ampere. That half of this current, because it is 400 and this is also 400, and this current also what? 1 by 20. Is it clear? Is it clear? So the two currents here are 1 by 20 each, 1 by 20 ampere. That is half of the incoming current 1 by 10 ampere. Is it clear to you? Is it clear to you? The concept is clear to you? Really sorry. Really sorry. So see, due to this 1 by 200 ampere current, there will be a drop of what? Due to this 1 by 200 ampere, 1 by 220 ampere current, 1 by 20 ampere current, there will be a drop of what? Some voltage drop across this 400 ohm, right? So I can write like drop across 400 ohm will be equal to this first branch, right? 400 ohm will be equal to 1 by 20 into 400. V is equal to I into R. So it will be 2, right? Is it correct? 20, right? So 20 volt. Is it correct? So drop across 400 will be 2 to 1 by 20 ampere. So 1 by 20 into 400, it will be 2 times 20, right? 2 times 20. So 20 volt. That means if this is 20 means this also what? 20, right? Because this is parallelly connected, no? If this is 20 means this also 20, right? This is 20 means this also 20. Is it correct? Or in other words, if this is 1 by 20 ampere, no, the effective combination I already said that it will be what? 200 ohm. If this is 100 means what is the value of Rx now? The value of Rx will be equal to what? If this is 100 means this also be 100, then only the whole combination will be 200. Sorry, this is 100 means this is what? 300, right? Sorry, this is 100 means this is 300. Then only the whole combination will be what? 400. Then only that 400 in parallel with the 400 makes the effective value of resistance 200. Then only that 200 will be equal to this 200. Is it clear? So we can write the value of Rx will be equal to what? 300 ohm, right? You see, it is 300 ohm. It is 300 ohm. Is it clear? That means due to 1 by 20 ampere, there is a drop off. So the drop across Rx will be equal to, or 300 will be equal to 1 by 20 into what? 300. 1 by 20 into 300, right? This is nothing but what? Rx, right? This is Rx and this is Vx, right? So you know the value of Rx, that is 300 ohm, and 300 into 1 by 20 will give the value of drop. So 1 by 20 into 300 is nothing but 2 and 2 15, so it is nothing but 15 volt. 15 volt. So the drop across Rs is nothing but Vx. So this is the answer. Let's check the answer. Yes, it's correct. So this is the concept. See, the concept is actually something you have to know. Otherwise it's very difficult to solve such a problem. You have to know the basics. You have to imagine what is happening in the circuit. Then only you can solve a problem like this. At the first look itself, you may feel that it is easy, you can solve, but there is something you have to really utilize. That's nothing but your brain. Okay? Then only this can be utilized. We can be solved. This problem can be solved in other method also, right? I can solve in that manner also, so that you will feel more confident. Okay? That means method 2. How can I solve? See, if due to this 1 by 20 there is a drop of what? 20 volt, right? So this branch also will feel a total voltage drop of what? 20 volt, right? That means this across it is connected. That means these and these will be parallel. In parallel branch voltage will be same. So if this is the drop across this 400 ohm is 20 volt, means the drop across this 100 ohm plus this Vx will be equal to what? It is also 20 volt. That I can write like 100 into 1 by 20 plus Vx will be equal to what? 20. Or I can write like 5 plus Vx equal to 20, or simply Vx equal to what? This is also another method. No issues there. In both the cases you will get the same answer. No issues there. No issues there. Did you get the idea? Okay. Can we move to next problem? Is it clear to you? Is it clear to everybody? Okay. See, the problem is actually easy, but unless you know the basics, unless you know the basics, so this is the type of question you may expect in a very standard examination. So see next question. So you got the idea of how can we use substitution theorem, right? 6 volt, it is R, and this is 4 ohm, and it is 20 volt, right? 20 volt. Okay, cool. This is considered to be load, right? This is considered to be load. Determine R such that, question is, determine R such that determine R such that maximum power across load. Maximum power across load. Is it clear? How can we find? How can we find? See, here also you have to determine the value of R so that maximum power across the load. That is, you can apply maximum power transfer theorem here also. Maximum power transfer theorem here also you can use. But how? How can we use? How can we use? See, okay. See, how can we solve this? This also DC circuit, no? So there is no need to confuse in terms of what AC, ZL, RL is variable, SL is variable. No need to think of because it is simply a DC circuit, no? So it is 20 volt. So this is 4 ohm means for maximum power transfer, I can write like for maximum power transfer, right? Power transfer, maximum power transfer, the load value equal to what? 4 ohm, right? For maximum power transfer, the same value will be here also. Then only RL will be equal to R Thevenin or RS. RL will be equal to R Thevenin. This is 4 ohm, right? R Thevenin is 4 ohm, no? So R Thevenin equal to RL condition only satisfy if this effective value of this load will be equal to what? 4 ohm. Okay, that means, see, okay, suppose any method you can apply. Any method you can apply for find that value of R. Okay, any method you can apply. Again I can apply substitution theorem now. Again I am going to apply substitution theorem. So by substitution theorem, the circuit will be modified like let be Rx and let be 6 volt. Let be 6 volt and let be R. Okay. So we have to find the value of R only. Okay. So suppose there is a flow of current I. You imagine there is a flow of current I here. Then apply KVL in this loop. What I get? It will be 20 minus 4I minus I into R, right? Minus 6 volt, right? Minus 6 equal to 0. Or in other words, I can write like, okay. So see, beta, what is this effective value? It will be equal to what? It will be equal to 4 ohm, right? That means I can write like 20 minus 6, it is nothing but what? 14 minus I into 4 plus R equal to 0, or simply I is equal to 14 divided by 4 plus R. So let be equation number 1. So you got the value of I is equal to 14 divided by 4 plus R. Okay. And one more thing you have to notice, since the effective value of this will be equal to what? 4, right? The effective value of this circuit will be equal to what? 4 ohm. That means the total current I will be equal to, but according to maximum power transfer theorem, the load side, this side, effective value of load equal to 4 ohm, so that this is also 4 ohm, right? So current I in the circuit will be, current I will be equal to what? 20 divided by 4 plus 4, right? Is it correct? 20 divided by 4 plus the effective value of this will be also what? 4, which is nothing but 20 divided by 8, or which is nothing but, what is beta? 10 by 4 or 5 by 2 or 2.5. 2.5 ampere, right? So I, you got what? 2.5 ampere. Substitute the value of I in this equation. So let be, this I will be equal to what? 2.5 ampere, it will be 2. Substitute this I value in equation number 1. So substitute in 1. Substitute in 1, I will get 2.5 will be equal to what? 14 divided by 4 plus R. Or I can write 2.5 into 4, what is beta? It is 10, right? 10 plus 2.5 into R equal to 14, right? So I can write 2.5 R will be equal to 4, or R will be equal to 4 divided by 2.5, or will be equal to 20 divided by 40 divided by 25, or in other words it will be equal to 5. So R will be equal to 8 by 5 ohm. So this is the final answer. This is the final answer. This is the final answer. In any method, no, you can use alternative method also. You can use any method to solve this problem. But you should be always take care of that the concept is clear. You can't make any fault here. That means your base or your concept will be clear. Then only the final answer will get. Okay, let's check the answer. The value of R will be 8 by 5 ohm. Yes, it's correct. It's correct. It's correct. Is it clear? Is it clear? I think it's clear to you. No doubt at all. Okay. So simply the concept here it is maximum power transfer concept. That means this RL will be equal to this. RL will be this load side RL will be equal to this RS or RThevenin. Then the effective value of this will be equal to what? Effective value of this will be equal to this one, 4 ohm. So from that we got some conditions and solve that condition, we will get the answer. We will get the answer. Okay. So this problem also hardly needs what? Maximum 30 to 45 seconds only if you really know the concept. Okay. Less than 1 minute you can solve this also. Okay. So this is the concept. Is it clear to you? Is it clear to you? Any doubt anywhere? Okay. Can I move to next session? So anyhow you have to reach the answer. That is our aim. That is our aim. Anyhow you can reach. There are no strict rule that you can follow only this method, only that method. There is no need at all. After you what? After you learn all in electrical, I mean all subject in electrical and electronics engineering, some problems now you can use many subjects to solve that specific problem. That you will learn quickly. Okay. After you complete all the syllabus in electrical and electronics engineering, if someone is given a question, then it will be solved by many ways. Okay. That you will learn. So next we have to see dual of a network. Next we have to see dual of a network. Dual of a network. Dual of a network. See, dual of a network means you have to convert the certain values into certain other values. So if someone asks you to find what is the dual of a certain network means, you have to convert some values into another value. Bas. Some values into another value. That is the dual of a network. That means duals. So dual of V of t will be equal to I of t. Dual of R will be equal to G. G is nothing but conductance, right? Dual of C will be equal to L. dual of C into dV by dt equal to L into dA by dt. Dual of C into dV by dt equal to L into dA into dt. Dual of Thevenin theorem equal to Norton theorem. Dual of KCL equal to KVL. Dual of KCL will be equal to, not actually it is arrow, singular, right? Dual of KCL will be equal to dual of KVL. I mean, if you have to find, okay, when doing some example, you will definitely clear, you just note this, okay. V of t will be converted into I of t, R will be converted into G, C will be L, C into dV by dt will be L into dA by dt, Thevenin theorem will be converted into Norton theorem, KCL will be converted into KVL, and series connection will be converted into parallel connection. Series connection will be converted into what? Parallel connection. Series connection will be converted into parallel connection. So that's all for dual. Okay, and voltage source will be, that is V of t will be I of t, that is voltage source will be converted into current source. Voltage source will be converted into current source. Okay. And one more thing, open circuit will be converted into short circuit, and Z will be converted into Y. Z will be converted into Y, that is admittance. Impedance will be converted into admittance. Okay, let's do an example, then it will be very clear to you, very much clear to you. Okay, let's do an example. Also, nodal will be converted into mesh. Nodal will be converted into mesh. Okay, let's do an example, it will be very clear. And one more thing, star will be converted into delta. So dual of star is nothing but delta. Okay, let's write a question. Let's write a question. So this is the question, find dual. Find dual. That means this is a simple question. No, in your option there may be some circuits, you have to pick one circuit which is exactly the dual of this circuit. So you have to use this table or this concept in order to convert it into dual. So find dual, simple, that is the question. Okay, so I already said that for getting the dual of this circuit, you have to convert each parameter to dual term, each parameter into dual terms. That means you have to convert voltage into current, you have to convert resistance into conductance, you have to convert inductance into capacitance, you have to convert capacitance into inductance, you have to convert series into parallel, you have to convert parallel into series. Is it right? But remind one thing, when you are doing or when you are making the dual of certain network, that means only unit will be changed. That is, I can write here, only unit will change, not the value, not the value. This is very, very important. This is very, very important. Only unit will change, not the value. Okay, let's see what is the dual of this network. See, this is V of t, right? So what is the dual of voltage? It is nothing but I of t. So I can write like this. I can write this is I of t. So voltage source will convert into current source, no? So the arrow will be there. And There is a series resistance, right? 2 ohm. That is converted to what? Parallel. And its value will be 2 mho mho. 2 mho. Mho is nothing but ohm raised to minus 1, because R is converted into G. G is nothing but what? 1 by R. G is nothing but what? 1 by R. That is the conductance. So this 2 ohm in series will be converted into 2 mho, or 2 raised to 2 into ohm raised to minus 1. Mho means ohm raised to minus 1, nothing but, okay, mho. So 2 mho in parallel, and again this 3 Henry, that is the inductance. So inductance will be converted into what? Capacitance, right? C, dual of C is equal to L means dual of L is equal to what? C. No issues there. So that also in series, no? So that will be converted into what? Capacitance. And the value will be 3 farad. That means you can change the unit. Unit is Henry. Henry to farad only. You can change inductance to capacitance, but you can't change the value. That is, only unit will change, not the value concept. Only unit will change here, not the value. So you can convert 3 Henry to 3 farad only. 3 Henry to 3 farad in parallel connection. And this is also right, series now. So you can convert this also in parallel. That means 4 farad. Is it correct? Is it correct? So that is the concept here. You can use that. Sorry, it is 4 Henry. So inductance is Henry now. So we changed the unit, not the value. Is it correct? Is it correct? So this is the dual of what? This network. So in objective type examination, you may ask like this also. You may ask like this also. Something is given, some network is given to you, and you have to find the dual of the network. Simply you can apply this, you will get the answer. You will get the answer. Okay, let's do one more thing. Let's do one more question. Okay, let's do one more question. Let's do one more question. Again find a dual. Find a dual. It's 10 volt, right? 10 volt, okay. How can we find the dual? How can we find the dual? See, let's take, right, this voltage will be converted into what? Current, right? This voltage source will be converted into what? Current source. So it will be 10 ampere, right? It will be 10 ampere, and this 10 ohm in parallel will be converted, series will be converted into what? 10 mho in parallel, right? 10 mho in parallel, and this 5 Henry in parallel will be converted into what? 5 farad in series, right? 5 Henry in parallel will be converted into 5 farad in series, right? And this 1 ohm in series will be converted into 1 mho in parallel, right? 1 mho in parallel, right? And this capacitor 2 farad is converted into, this is parallel, no? This is series, no? This is series, no? So it is converted into 2 Henry in parallel. 2 Henry in parallel. So that is the what? Dual of a network. That is the dual of a network. That. So we learned about the concept of duals, no? We learned about the concept of dual. So you can simply convert one circuit into another circuit. That is the dual of the circuit. Okay. If you want to, in the question, if you want to find the dual means, you can simply convert the circuit, and remain all the time that you can't change the value. You can only change the units, right? You can only change the units. Okay, let's move into another topic. That is nothing but AC analysis. That is nothing but AC analysis, right? AC analysis. So I think you know the basics of AC, right? How AC generated, and so that, like, due to electromagnetic induction and Faraday's laws of electromagnetic induction, there will be what? Whenever a coil is situated in a time varying magnetic field, or a coil cuts the stationary magnetic field also, there is a chance of producing alternating current in the coil. That is how we can generate AC. So that is not our syllabus, right? How can we generate AC? That we don't need to focus on that area. We will focus on something which is very interesting, that is called the RMS value. But before that, a voltage, it is AC in nature, can be represented like V is equal to Vm sine of omega t plus phi. It's very, very important. You have to find each term now. You have to find each term. Where V is nothing but the instantaneous value. And Vm is nothing but the maximum value. That is, if this is the waveform, this is Vm and this is V of t, okay, and this is omega t axis, and this is pi, and this is 2 pi. So this is the waveform of an alternating voltage, which is change at every second. Every point of time it is changing. That's why it's called alternating voltage. It is alternating in nature. For there is a positive half cycle and there is a negative half cycle also. And Vm is nothing but the peak value or maximum value of the voltage, right? Peak value or maximum value of the voltage is represented as Vm. And 0, pi and 2 pi, where 2 pi is nothing but the time period. 2 pi is nothing but the time period, right? So 2 pi is nothing but time period. And here is minus Vm also, right? Minus Vm also. And peak to peak value is nothing but this value. V peak to peak. Or it is nothing but peak to peak value, V peak to peak. And its values will be nothing but final value minus difference value, final value minus initial value, or simply 2Vm. So peak to peak value is nothing but what? 2Vm, right? That means this value minus this value is equal to 2Vm. Up to here it is Vm, again up to here to here it is Vm. So total will be what? 2Vm, that's nothing. And this is the simple alternating voltage waveform, and Vm is the maximum value, and omega is nothing but angular velocity in radian per second. These all are basics, no? These all are basics, you know this. And phi is nothing but the phase angle. That means the angle at which in radian, okay, phase angle in radian. And t is nothing but the time in seconds. So these are some important parameters regarding an AC voltage waveform. In same manner, current wave also. T is the total time, no? T is the total time period. That means, what is the meaning of time period? Time period is nothing but it is a time taken to complete a cycle. And after the end of that cycle, a new cycle will repeat. That means it is started from here, no? And it's come here, and come here and ends here. And after this, a new cycle is going to start. So time period means it is a time taken to complete one cycle, right? It is a time taken to complete one cycle is called a time period. And there is a relationship between time period and frequency. That is nothing but T is equal to 1 by F. T is equal to 1 by F. So frequency is nothing but number of cycles per second. That is called the frequency. Number of cycles per second. In 1 second, how many cycles like this going to pass? Going to pass. For example, in our home now, the standard voltage that we are receiving is 50 hertz, 230 volt 50 hertz, right? 230 volt 50 hertz. So the meaning of 230 volt 50 hertz is nothing but 230 is the RMS value voltage, right? 230 is the RMS value voltage. 230 volt 50 hertz. 50 hertz is nothing but the frequency. So frequency is nothing but in a second 50 cycle like this will be passed in our home, or we are receiving in a seconds 50 cycles like this. That means 1 cycle, 2 cycle, 3 cycle. Like that you will receive 50 cycles per second in our home. That is the meaning of 50 hertz. That is the meaning of 50 hertz, right? Okay. So that are some parameters in AC. So okay, so let's move to a very important concept that is called the RMS value. It's very important. Very important. RMS value. It's very important. RMS value. Okay. Consider a circuit, and in this circuit there is a voltage of V of t. AC circuit, no? Consider an AC circuit, right? Consider an AC circuit consists of resistance R. The voltage, instantaneous value of voltage is V of t, which is nothing but V of t is equal to Vm sin omega t plus phi. And I of t is the instantaneous value of current. So due to this voltage and this resistance, there is a flow of current I of t, of course you know. So I am observing this circuit for, I am passing a current voltage of V of t and there is a flow of current I of t, and I am observing this circuit for 5 seconds. 5 seconds. And I found that, of course no, whenever a flow of current, whenever there is a flow of current in a resistor, there will be heat, there will be of course heat, no? There will be some loss of energy, right? So that energy is nothing but I square into R, right? No, that I square into R. So in that 5 seconds, I observed that there is a loss of, or there is a heat of 50 joule. There is a heat 50 joule. Is it clear? So in 5 seconds, there is a 50 joule heat produced in this circuit. Okay. And I consider this is one circuit. I consider another circuit that is DC in nature. The same circuit, but I changed the what? VDC. Okay. And there is a flow of current I, capital I, because it is DC no and VDC no, simply V or VDC, okay, anything you see, and R. And for the next circuit, I also observed this circuit for 5 seconds and observed the circuit until 50 joule produced. Observed the circuit for 5 seconds and I adjusted my VDC value in order to produce 50 joule heat in 5 seconds. Did you get the idea? See, initially I gave an AC, I produced 50 joule in 5 seconds. In the next circuit, I simply remove the source and replace it with a DC source. Replace it with a DC source, right? Replace it with a DC source. And there is a current, of course, there is a current and there is a resistance R. There is no change in this R value, it is same. There is no change in the time period of operation, it is 5 seconds. But I can adjust the value of VDC so that within the span of this 5 seconds, within this time period 5 seconds, I have to produce 50 joule heat. Then what will be my VDC? What will be my VDC in order to produce 50 joule heat in 5 seconds? In order to produce 50 joule heat in 5 seconds. That is the meaning of RMS value. It's very, very important, beta. It's very, very important. You know, you may learn a theory like the concept of RMS value. It is the effective value reduced to the same heating effects that of, you heard that? It is the effective value required to produce the same heating effect as that of AC can. This is you learned, right? This is you learned, right? But I think 70% of the people here don't know the meaning of what is actually RMS value means. What is actually RMS value means? They know the definition. They know the equation Vrms equal to Vm by root 2, Irms equal to Im by root 2. They know the equation. But 70% of the electrical students don't know exactly what is RMS value means. What is the essence of the RMS value? What is the real feeling of that RMS value? They don't know. They don't know. This is the feeling. Now, you applied an AC circuit. In the second case, you applied a DC circuit with the same R value, with the same period, same time period, in order to produce same heating effect. How much DC you have to apply? That DC value is termed as the RMS value. That DC value is termed as the RMS value. That VC value termed as the RMS value, right? Of course, it will be vary from this form. It will not be equal to V of t. We know that. Whether it is less or whether it is high compared to AC. That we have to find. That we have to find with a simple proof. Then only we will find, oh, this is lower than that AC. Oh, this is higher than that AC. Then you will find the answer. Then you will find the answer. Okay. So let's see what it is. So RMS value is nothing but, now you can move to the definition. Now you can move to the definition. It is the effective DC value required to produce same heating effect as that of AC can in a same circuit in a same time period. That is the definition. That is the definition. Is it clear, beta? Is it clear? That means in a same circuit you have to produce the same current, same power, your energy in a same time. So that you have to adjust, definitely you have to adjust VDC. You have to increase or you have to decrease VDC. That we will find later. Whether you have to increase or decrease, that we will find later. But definitely you have to change this VDC, right? The same V of t, suppose it is 5 volt, means you can't apply 5 volt here. You have to adjust to some value. Then only you will produce 50 joule in 5 seconds.